Good morning, students. Good morning to all. Yesterday, we discussed about some basic concepts of alcohols, phenols, and ether. See, alcohol, its nomenclature, then nomenclature of phenol, and nomenclature of ethers. And even we discussed about the structure of ether, alcohol, and phenol. Today we shall discuss about the preparation of alcohols. See, dear students, in yesterday's class we discussed about nomenclature. We shall have one or two examples. Take for example, say CH3O, C2, CH2. That means CH2, again CH2, again O, CH2. See, we have 2-methoxy group. So it can be represented, its IUPAC name is, see, we have only one carbon atom, 2, which is nothing but an ethane, and 2-methoxy groups are there. Therefore, it is dimethoxy ethane. Its IUPAC name is dimethoxy ethane. See, dimethoxy ethane. To go, for example, a phenol compound. So this is nothing but phenol. See, we have two substances, methyl substance on this. Its IUPAC name is, the base compound is phenol, and the number of the carbon atom 1, 2, 3, 4, 5, 6. Therefore, 2, 6, 2, 6, dimethyl phenol. So easily we can represent the IUPAC system. Are you clear? So it is nothing but 2,6-dimethyl phenol. Okay, this is nothing but the IUPAC nomenclature of phenol. And we shall continue our discussion on other part, which is nothing but the preparation of alcohol. In preparation, we have to study the acid catalyzed hydration of alkene. From alkene, we can easily prepare alcohols. So we shall discuss about preparation of alcohols. See, all the nomenclature, you have to go through it, and many examples are there in textbook. You have to practice. Okay. Now we shall study preparation of alcohols. See, in preparation of alcohols, we shall study first one. It is from alkene. Say, acid catalyzed hydration gives alcohol. See, it is nothing but an alkene where carbon to carbon double bond is there, and when it is hydrolyzed, that means hydration of alkene in the presence of mineral acid. So we will get C again. Here this double bond addition takes place, and you will get, this is nothing but OH, which is nothing but an alcohol. Are you clear? So this water molecule and which is electron rich. So, in the presence of an acid, and therefore this particularly it is called acid catalyzed hydration of alkene. Alcohols are prepared by acid catalyzed hydration of alkene. See, particularly you can take an example. See, CH3, CH double bond, CH2. So, which is nothing but propene, Pro 1E. See, when it is hydration or hydration in the presence of mineral acid, see, we will get CH3, CHOH and CH3. So we will get propane 2-ol. We will get propane 2-ol. Are you clear? We will get propane 2-ol. See, very simple reaction. It is nothing but propene. See, this propene on hydration, it is nothing but a water molecule in the presence of an acid. So we will get propane 2-ol. See, this takes place according to Markovnikov's rule. You studied in first stream. In Markovnikov's rule, the secondary carbocation is more stable than primary. See, in presence of a nucleophile here, and H plus, the hydroxyl group attached to a secondary carbon. Therefore, it is according to Markovnikov's rule. Are you clear? What is Markovnikov's rule? You studied in last year. Here, acid catalyzed hydration, addition of an hydroxyl group to a propene takes place according to Markovnikov's rule. Okay, this is nothing but preparation of alcohol from alkene. It undergoes mechanism. So you have to study mechanism of acid catalyzed hydration of alkene. Mechanism of acid catalyzed hydration of alkene. You have to study. So this is a general equation. In general equation, you can find what are the changes. You can easily remember. So I'll move on to next. It is nothing but mechanism. We shall study mechanism of acid catalyzed hydration. Acid catalyzed hydration of alkene. Are you clear? So it is nothing but mechanism of acid catalyzed hydration of alkene. It undergoes by 3 important steps. So first step is nothing but protonation of alkene. See, first step is nothing but protonation of alkene by alkene to form it will form carbocation. Okay, so it is first, take for example, it is nothing but hydration, water. So in the presence of H plus, so you will get H3O plus, which is nothing but their acid. Okay, then it is nothing but an alkene. See, in this alkene we have H3O plus, see, which can be written as HOH, and it is nothing but another H, which is a positive charge. So this proton is absorbed by alkene, which is an electron rich center. Earlier, so you will get it is a reversible reaction. So it is a mechanism. Very clearly I have to show. So which is nothing but a hydronium ion, and you can find here the formation of carbocation. So the carbocation is for and water molecule. So one of the H atom is here, and this is nothing but carbocation by the removal of water. Are you clear? So here we have to particularly mention the charge, which is nothing but carbocation. Carbocation. Understood? So this is the first step, which is nothing but a proton is added to an alkene, and double bond will become a single bond. Clearly read. See next, attack of in second step, attack of water molecule takes place. So we have carbocation. See, which is plus here, and again these are the protons. Water molecule H2. So it has a lone pair, it attacks on. So you will get again. See, water molecule attacks on carbocation. Then carbon. See, we have here, which is nothing but in water. Then okay. So this water molecule attacks on it. And in the last step, see, deprotonation takes place. See, one of the proton is eliminated. So you will get, see, as it is, you have to write carbon. So again another carbon. So we have a water molecule here, H, and which is nothing but plus. So we will get an alcohol. C, then C, and here is nothing but OH. Are you clear? See, which is nothing but an alcohol. Are you clear? See, as water molecule is here, and we will get H3O plus. H3O plus is removed. Are you clear? Understood? So this is nothing but deprotonation. It is nothing but deprotonation. Are you clear? See, go through it very clearly. Understood? Dear students, I will repeat again. So this is nothing but a first step, and this is nothing but a second step, and this is nothing but a third step. See, carbon to carbon double bond, which is nothing but an alkene, This alkene reacts with an hydronium ion, and we will get a carbocation. So that means alkene is protonated. For an alkene, one of the H plus ion is added. And again, attack of water molecule. So you will get what? Here, a compound where the water molecule attacks on the carbocation. See, what is the product in the right side? Then you have to take the opening reaction in the second step. In the first step, product is nothing but the second step. Then second step product is in the first step. And finally, the acid hydronium ion releases. Catalyst is a substance which does not take part in the reaction. Are you clear? And this is called acid catalyzed hydration mechanism of alkene to alcohol. By the addition of water molecule, we will get an alcohol in the presence of an acid. And every year, which can be asked for 3 months. Three steps very clearly have to write. First is protonation of alkene to form what? Carbocation by the nucleophilic attack of H3O+. Okay? Then in the second step, the attack of water molecule to a carbocation. So carbocation, which is deficient in electron, So water molecule, oxygen which is rich in electron interacts. And deprotonation takes place. One proton is removed and the proton which is added, which is act as a catalyst from the acid, so it is removed. So this is nothing but mechanism of acid catalyzed hydration of alkene to form alcohol. To form alcohol. Okay, we shall study next part, which is nothing but the preparation of alcohol by diborane. By diborane. See, this mechanism plays an important role. You have to study well, you have to practice all the 3 steps. Repeatedly you have to write, then only we can able to write in your annual examination. Are you clear? So we shall study next one. Next one. Preparation of alcohols from diborane. Diborane. So second one from diborane. Diborane. See, when alkene, take for example particularly say CH3, CH double bond CH2. Say it is nothing but propane. When propane reacts with diborane, CH, BH2. So you know about diborane, B2H6. B2H6. You studied in P block elements. Last year you studied diborane, which has a banana bond. So diborane structure. So it is nothing but twice, and here 6 twice. Here 3 molecules on continuously attack. We will get see tripropyl fluoride. We will get see CH3, CH2 and CH2, 3 times fluoride. So which is nothing but 4. Are you clear? Continuously, see one of the hydrogen atom attacks on the propene molecule, and finally this on. See, when it is treated with NaOH, along with hydrogen peroxide. So we will get 3 times CH3, CH2, CH2OH. So which is nothing but propane 1 all. We will get propane 1 all. Are you clear? So in the presence of hydrogen peroxide, here we will get an alcohol according to anti-Marconi formula. See, the hydrogen atom adds to the molecule which contains less number of hydrogen atom, less number of proton. It takes place only when in presence of peroxide. Here particularly we use hydrogen peroxide, and it is particularly oxidation. Are you clear? Here boration, hydroboration and oxidation. For diborane, when an alkene is treated with diborane, we will get tripropyl borane. CH3, CH2, CH3, 3 times borane. Boron. Then when again it is oxidized in the presence of an alkali, with hydrogen peroxide, according to anti-Marconi rule, the product obtained is propane 2 all. CH3, CH2, CH2OH. By this method, we can prepare alcohol. Are you clear? So it is nothing but boration and as well as oxidation. Boron attaches 3 molecules of propane, which is nothing but converted into propane. And finally, on treating with hydrogen peroxide in the presence of an alkali, we will get alcohol. Therefore, it is called propane 1 all. So this is nothing but the preparation of alcohol from alkene only by using dibordane. By using dibordane. Are you clear? Okay. We studied two important preparations. One is acid catalyzed hydration of alkene. Another one is boration of alkene by using dibordane. Okay. We shall study next preparation. Next preparation. See, next is we can prepare alcohol from aldehydes and ketones. From aldehydes and ketones. Preparation of alcohol from aldehydes and ketones. You know aldehyde, which is nothing but RCHO. So when it is hydrogenated, in presence of the catalyst like platinum, palladium, and even nickel, on reduction, and this is nothing but reduction. On reduction, we will get CH2OH. Are you clear? See, an aldehyde is converted into an alcohol. This is a general equation. So we can take CH3CH4 plus H2. So we will get in presence of platinum or palladium as a catalyst. So we will get CH3CH2OH. Okay. So this is called reduction. So addition of hydrogen takes place. Okay. Here RCHO, when it is treated with hydrogen on reduction. So whatever the favorable condition, that is the catalyst. The catalyst we can use either platinum or palladium or nickel. See, in the preparation of alcohol from aldehydes and ketones, if we use aldehyde, we will get primary alcohol. And if we use ketone, we will get, say, RC double bond O R dash. So, which is nothing but a ketone. It is a general reaction when it is again hydrogenated. In the presence of, so always this reaction takes place under reduction. See, other important strong reducing reduction agents are, see, lithium aluminium hydride, or even sodium borohydrate, NaBH4. See, all these are very good reducing agents. And we will get here RCHOH, then alright. So which is nothing but a secondary alcohol. When ketones are used, we will get secondary alcohol. Are you clear? See, as lithium aluminium hydride, which is costlier, so we can go for, again, when this an aldehyde can be converted into ester by treating with an alcohol, and again it is reduced, we will get an alcohol. Are you clear? So here you have to remember the reducing agent like lithium aluminium hydride and sodium boron hydride, and as well as catalyst like platinum, palladium, or even nickel can be used. Are you clear? So this is nothing but preparation of alcohol from aldehydes and ketone. When ketone is used, we will get secondary alcohol. When aldehyde used, we will get primary alcohol. So we are completed preparation of alcohols, three important reactions. Okay, we shall continue our discussion on next, which is preparation of alcohol by carbonate compounds by Grignard reagent. See, from Grignard reagent, got important preparation from Grignard reagent. Clear? You can use from Grignard reagent. See, in Grignard reagent, see we did in RMGX. We studied in haloalkane and haloarine. See, this is nothing but a Grignard reagent, RMGX. See, and carbonyl compound, take for example, C double bond O, a carbonyl compound. Either it may be an aldehyde or ketone. See, when it is treated with a Grignard reagent, RMGX. RMGX. So, this is ionic and this is covalent. What is Grignard reagent? How it reacts? Why it is active? We studied in last topic. This is nothing but haloalkane and haloarine. See, it forms an adduct. You can easily find it. See, this carbon, again this oxygen combines with this is nothing but R. So, this R is the same. And oxygen bridges with magnesium and X. This is an adduct. This is an adduct. Are you clear? So, when this adduct is formed, on hydrolysis, on warming with, if it is warm with water, we will get say R, then CH2OH. Are you clear? And plus MgX and OH. So this will be the other product. So this is nothing but alcohol. If we use here ketone, same we will get a secondary alcohol. Say this is nothing but preparation of alcohol from Grignard reagent. Preparation of alcohol from Grignard reagent. In Grignard reagent, a carbonyl compound like aldehyde or ketone made to react with Grignard reagent RMGX. It forms an adduct. Which is called an intermediate compound. And this intermediate compound, on warming with water, we will get RCH2OH. Are you clear? Very simple. So this is the preparation of alcohol from Grignard reagent. We concentrate on the reaction. When Grignard reagent reacts with a carbonyl compound and it forms an adduct which is called intermediate compound, warming it with water, we will get alcohol. So we shall write the reaction with ketone. See, here it is nothing but ketone, C double bond O R dash, and when it is treated with a Grignard reagent, we will get C R, then another R, see this is R, and again adduct MgX. So we will get tertiary alcohol R, see R, again R dash, again R double dash, and OH. Again the same, magnesium bridges with hydroxyl as well as X. So this is nothing but a tertiary alcohol. We can easily prepare very simple reaction. When Grignard reagent reacts with ketone, we will get a tertiary alcohol. Are you clear? Okay. So this is nothing but preparation of alcohol from Grignard reagent. Okay, this completes our study of preparation of alcohols. So we shall study next part. So today we discussed 4 important preparation of alcohols. That is from Grignard reagent, then from diborane, again acid catalyzed hydration, and from aldehydes and ketones. In aldehydes and ketones, we have to do reduction. That's all. It is nothing but a reduction. So we shall continue our discussion on preparation of phenol. Preparation of phenol. How phenol is prepared. Are you clear? How phenol is prepared. See, phenol is prepared among four reactions we have to study. See, which is nothing but phenol. See, you studied in haloalkane, haloarenes, which is nothing but chlorobenzene. It is nothing but chlorobenzene. Chlorobenzene. When chlorobenzene is treated with an alkali, NaOH. So drastic condition you have at a high temperature of 623 Kelvin temperature and nearly 320 atm pressure. So this is nothing but reaction of alkali to chlorobenzene, haloarene. See, it is strongly bonded to sp2 hybridized carbon. It is very difficult to remove the chlorine atom, which is bonded by more number of electrons are there as it is sp2 hybridized carbon atom. So therefore, drastic condition is required. Maintaining a 320 atm pressure means it is a high condition, a drastic condition. Then only we can remove chlorine atom from it. So we will get ONA. So again, on acid treating with mineral acid, we will get phenol. Okay. So this is the preparation. From chlorobenzene, how phenol is obtained from chlorobenzene? Simple 2 marks question. When chlorobenzene is heated with an alkali NaOH to form sodium hydroxide. On acidification, treating with HCl acid, it gives phenol. Are you clear? Simple reaction. Okay, this is first method of preparation of phenol. In second method, say chlorobenzene reacts with an alkali in what are the drastic conditions? High temperature and pressure. We will get sodium hydroxide, and on acidification it will give phenol. This is nothing but preparation of phenol. Okay. The next, in second method, when phenol is treated with, say, how to obtain phenol? So it is nothing but a benzene. When it is treated with oleum, H2S2O7, which is called oleum. Fuming sulfuric acid is called oleum. So it gives, benzene sulfonic acid. What it gives? It gives benzene sulfonic acid. Are you clear? It gives benzene sulfonic acid. See, this benzene sulfonic acid, again, we have to treat it. So this is nothing but a preparation of phenol. From what? Benzene sulfonic acid. On warming with water, we will get phenol. So this is nothing but phenol. Are you clear? So this is the second method of preparation of phenol. Again, phenol is also obtained by aniline. See, you studied this in your first talk. So this is nothing but aniline, which is called, see, primary aromatic benzenes. So aromatic ring on amine group is added, which is nothing but aniline. When aniline is treated with nitrous acid NaNO with HC at 273 to 278 low temperature. So we will get benzene diazonium chloride. So which is nothing but N2Cl. Are you clear? Minus and plus carries the charge. So this is called benzene diazonium chloride. What is the name of this compound? So it is nothing but benzene diazonium chloride. Are you clear? Again on hydrolysis, so you will get phenol. So it is nothing but phenol. So nitrogen gas and HCl. Are you clear? Very simple equation. So therefore, phenol can be prepared by three important methods. One is from chlorobenzene, another one is from sulfonated benzene, benzene sulfonic acid, another one is from aniline. From aniline. Are you clear? So aniline we will get an intermediate compound, benzene diazonium chloride. Are you clear? Which can be converted into phenol. Are you clear? Again, you have to study another important method for the preparation of phenol, that is preparation of phenol from cumene. Preparation of phenol from cumene. Are you clear? Preparation of phenol from cumene. So we shall study cumene process. We shall study cumene process. Always cumene process can be asked for 3 marks. How phenol is prepared? How phenol is prepared from cumene? So preparation of phenol, preparation of phenol from cumene, very important for your examination point of view. Preparation of phenol from cumene. What do you mean by cumene? Cumene is nothing but an hydrocarbon. And isopropyl benzene is called cumene. It is oxidized in air. It is oxidized in air. So this is nothing but cumene. Let's say cumene, benzene ring, again CH, here CH3 and CH3. So this is nothing but cumene. It is a hydrocarbon. So its name is isopropyl. See, we can find isopropyl, propane, isopropyl benzene. It is called isopropyl benzene. It is called what? Isopropyl benzene. So this isopropyl benzene, when it is oxidized in air, we will get cumene peroxide. What is the product obtained? Cumene peroxide. You can see cumene peroxide. Write the equation very clearly. See, which is nothing but a benzene ring and this carbon atom and this hydrogen. Just I will make a writing. See, this is nothing but CH3 and this is nothing but CH3, which is nothing but a cumene. When it is oxidized in air, see, two oxygen atoms attach along with hydrogen. So this is nothing but a hydrogen. Are you clear? Be careful about. So this is nothing but cumene peroxide. So this is called cumene peroxide. Are you clear? Just watch the equation. Are you clear? So which is nothing but cumene peroxide. And finally, which is hydrolyzed in presence of an acid plus. So we will get acetone and phenol. So here another compound we will get. So this is nothing but phenol, OH, and plus CH3, OCH3. Are you clear? So this is phenol, and this is nothing but acetone. Simple compound. So acetone is the major byproduct in this reaction. See, when cumene is oxidized in presence of oxidized in air, you will get cumene peroxide. Cumene peroxide, say on acid hydrogen, gives phenol and acetone. phenol and acetone. CH3COCH3, which is called acetone. CH3COCH3. Are you clear? And this is how phenol is prepared from cumene. See, write by word 1 mark, and for equation 2, 3 marks question. Always, if you go for any question paper, you have this question: how phenol is prepared from cumene. So cumene is oxidized in air to form cumene peroxide. Write the equation carefully, and then it is acid hydrolyzed to form phenol and acetone. Are you clear? See, again and again I am going to tell you. So this is very important concept for your examination. How phenol is prepared from cumene. Cumene is a hydrocarbon which is called isopropyl benzene. Write its structure: C6H5, CH, CH3, CH3. Are you clear? It is oxidized in air to form cumene peroxide, and that cumene peroxide on acid hydrolysis gives phenol and acetone. Are you clear? So this is nothing but preparation of phenol. In preparation of phenol, we studied about the cumene process, and then again preparation of alcohol. We studied 4 important steps, the 4 important preparations, and here phenol preparation also. Phenol can be prepared from chlorobenzene, again from benzene sulfonic acid, and again from ethene. Are you clear? And it is nothing but a manufacture or preparation from cumene. Always you see annual examination question paper, you will get one question. Okay, this is the preparation of phenol from cumene. Note down the reaction. See, while observing the online class, keep one your notebook and write all the equations. Are you clear? Okay, we shall move on to next. The physical properties of alcohols, phenols. Physical properties. We shall study physical properties of physical properties. Okay. In physical properties, generally you have to write about boiling point, and BP, boiling point, and another one is solubility. See, alcohols and phenols. They can form, see, alcohol, ROH. Phenol, which is nothing but a benzene ring, OH. It is nothing but a phenol. See, this alcohol and phenol, we can find among this intermolecular hydrogen bond. We can find intermolecular hydrogen bond. See, what about the boiling point of alcohol? As the carbon chain increases, boiling point is also increases. In a branched chain, the boiling point automatically decreases. Are you clear? See, here it shows more boiling point due to the presence of intermolecular hydrogen bond. It has an ability to form intermolecular hydrogen bond. This much you have to know. See, as you compare alcohol, phenols with hydrocarbon, haloalkane, haloarine, and even ether, but alcohol shows more boiling point than hydrocarbon, than haloalkane and haloarine of comparable molecular mass, even ether. So alcohol shows more boiling point than hydrocarbon, haloalkane, and as well as ether. It is due to the presence of intermolecular hydrogen. Are you clear? One point you have to remember. Again, go for phenol. Phenol, same thing. In phenol also we can find intermolecular hydrogen bond. Therefore, phenols, their boiling point and as well as boiling point is more. Any substitution is there, automatically boiling point decreases. In a long chain, if alcohols are there, then their boiling point is more. If it is branch chain, as the area is less in branch chain, automatically the boiling point is less. Are you clear? Okay. As molecular mass increases, boiling point is also increases. Alcohol shows more boiling point than hydrocarbon, than haloalkane, than ether of comparable molecular mass due to the presence of intermolecular hydrogen bond. We cannot find intermolecular hydrogen bond in hydrocarbon and even in haloalkane and even in ethers. Okay. You go for solubility. What about solubility? See, solubility. Solubility. Alcohols and phenols are soluble in water. Again, it is due to the formation of hydrogen bomb. They have an ability to form hydrogen bomb. They are soluble in water due to the formation of hydrogen bomb. Okay. In physical properties, one more question can be asked. Alcohol shows more boiling point than comparable mass of same hydrocarbon. Give reason. So it forms an intermolecular hydrogen bond. Hydrocarbon does not form intermolecular hydrogen bond. So therefore, boiling point of oxygen is more. You can easily write. Are you clear? Boiling point of alcohol is more than that of same molecular mass hydrocarbon, even ether and even haloalkane and haloarene. Are you clear? So that is nothing but the physical properties of alcohols and phenols. Okay, dear students, we shall stop here. Today we discussed about some of the chemical reactions and we discussed one of the mechanism and we discussed the preparation of phenol and physical properties of phenol, ether, that is phenol and alcohols. Okay. Okay, thank you.